in difficult, again, welcome everyone. Building, please note this point here. Building career in difficult skill, but which is going up, cutting edge, which is going up, is easy. Not immediately. It takes some time. Even for any skill, it takes time. You put a 3 months to 6 months, that's it, you're done. But you need to put consistent focus. The Databricks is leading skills in the market. And more than data engineering skill, this gives a foundation to get into enterprise AI. You all know everyone. Shanmuga is right. Everywhere you are seeing AI, right? AI is there. AI is not just another skill. It is going to be there. But it's very hard to break into as a career. You might know a little bit of AI, but as a career, breaking it is difficult. So then break into first data engineering. Data engineering, you can break into it. Good rate, good jobs. Then work a year or two. Then you can get into machine learning, enterprise AI. That's how it goes. Awesome. Let's get into, without wasting time, it's already 9:10. We just have 2 hours. So I'm going to discuss a 20-30 minutes, give some roadmap for you. Then Harun will give you a lot of hands-on practice. Then you need to take it and go home and do hands-on. When I say hands-on, you must run your code. You can take, copy and paste and run the code, see the results. Then after that, I want you to type. I want you to type read, write, read, write. Awesome. Does it sound good, Shanmuka? Does that help you?
It sounds good.
What we're going to do? Excellent, guys. Excellent. Very good. Okay, if you are not signed up for community edition, please sign up. This is how the Databricks looks. Left side, you will have menus like workspace. Workspace means it shows you what folders exist. You can create folders. You can create notebooks. Notebooks is the place you write your code. Notebook is the place where you write your code. Of course, this code can be put into Git. All those things you'll understand later, right? It's just such a general. Catalog is the catalog. Catalog, Ravi, Saira. What is a catalog? Catalog is simply, what databases, what tables. You're dealing with the data here. You will have these concepts of database in tables. So your catalog is nothing but what are the databases there, what are the tables are there. Right now I have only default, I have no tables when you see it. Okay. Don't worry about this. First, compute. Compute is where there is a server where you'll be running your programs on a compute, a cluster where you can able to create a compute here. Already you have seen this. Just focus on these three. Workspace is simply where you go and create folders. Catalog is where you see the tables. Compute is where you create your clusters. Okay. Right now, I create a simple cluster. You can able to create, which is up and running. I'm going to my workspace. You can create folders. I have created different folders. I'm taking a simple notebook. This is first notebook I already shared. This is the second notebook I want to share. So what I want to share is, in the last session, we have seen quickly some commands like this, where You're using Spark, Shanmuka, correct? You're using a Spark, you're reading. You need to know which format you're reading. Are you reading Parquet format or Delta format or JSON formats? How do you know? In your company, when you discuss with your team, you'll know where are the files. Where are the files? You need to know where are these data. You need to know what format. Then you will be reading it. Next, format may be Delta. Where are those files? Format may be JSON. Where are those files? All this information you get out of the discussions in the requirements. Hey, we are starting a project where I want your help to write some ETL programs, batch ETL programs. Then you will ask, hey, where is the data? What are the formats we're getting? Yeah, we have some JSON formats. We have some Parquet format. We'll be getting it. Where is it? Yeah, it is there in the storage, cloud storage. What cloud we are using? Azure cloud or AWS cloud. So AWS storage is S3. Azure storage is called ADLS. So those terminologies, you need to be very, very comfortable. Understand? So first, I want you to get a very clarity on how these systems work. Yeah, I want you to have good visualization. In a simple visualization, before you write any code, you need to be very clear why you are writing it. That is so important, right, Shanmuga? It is so important, especially when you're new to career. It's not a rocket science case. First of all, please understand, you don't need MS, actually. You don't need MS. In fact, anyone can understand this. Your undergrad is sufficient, but I'm glad you studied MS. Okay. Look here. Your job is you're going to do ETL. What is ETL, Anshu? Simply extract, transform, and load. Let's focus on first two. In the last class, we have focused on we extract means just reading. Loading means just writing. The meat is in transform. That is where Harni is going to give a lot of examples to you this week, even tomorrow, even next week. So we are writing let's go here, extract, transform, and load. Extract, Sairam. Extract means just read.
You just pull the data.
Exactly. You're reading. The most common way to read, Sairam, is read from cloud storage, correct? Cloud storage. Is there S3 or ADLS? Okay. So when you read, you see it as a Spark data frame. See, when I read spark.read, you store it as a variable. This variable is called a data frame. A simple word, data frame. Just like an array. Array is a word in programming you use. Like a vector, array, like that. So your data frame is nothing but a programmatic table. Saira, correct? When you close that program, your data frame won't be there unless you save it. Unless you save it. It's a programmatic table. Programmatic table. When you write a program, it's a kind of a variable. This variable, unless you store it in a table, when you really store it, you're writing to the storage. It means you're persisting it. It's something like this. In your laptop, you're doing a resume. Your laptop crashed. Shanmuga, all your changes won't be there, right?
Yes, all will gone.
It's gone because it's only during that time. It's like that variable is also like that. So, but when you store it, when you write it, so that is what it is. When you write it, you write to a cloud storage or you write to a table. Shanmuga, You can write to storage. Harun will show you today or tomorrow. You can write to a table. But when you write to table, it goes to the storage. So always say table, Sairam. When you say table, table is for human beings understanding. But behind the scene, it's a storage, right, Sairam? Is that correct, sir? Yeah?
Yes.
Absolutely. Of course, in Oracle and all, you don't really go and see where is that storage. Because Oracle stores everything as a binary files behind the scene. You just play with the tables. But in the big data world, you need to have good understanding about the storage. Because where is that storage? Is it on S3? Is it on ADLS? Is it on Databricks has its own storage, Databricks storage? How to secure it? All those things that comes into picture. Because this is a big data world where the data is easily portable. Tomorrow your company doesn't want Databricks. They can move that data from that storage or even cloud. They don't want AWS. They want to migrate it to Azure. Or they don't want Databricks. They want to use some other tool. They should be easily portable. They should not be locked. That's why these are called open systems, Sarah. So that's why you need to have clarity, what tables and what storage, all those things. Excellent. So you can read from even databases. That's not very common. You can read from a real-time streaming system like Kafka and Event Hubs. But when you read from the disk, we call it as a batch, because you read last 1 hour back, read again. That is a batch. Whereas in the streaming, you read from Kafka. There is a module for that. We will talk about that later. So look here. Databricks Foundation we've been discussing, and even we'll continue. But these two modules are this module 2 and module 4. Module 2 and module 4. So module 2 is PySpark batch processing. That's what it's about. You know how to read, you know how to write. Harun will help us how to transform. As you are loading it, you'll be loading into a tables. They store as a delta storage. What is that delta storage? All those things you'll be learning next 2 weeks, this week and next week. So I want you to focus on that very clearly. Okay, if you haven't come for the last week, please look here. This is I'm taking a simple, this one, a people data frame. I'm reading from it's a delta format. I'm loading means I'm reading actually from this. Not that load. Not this load. When you say ETL, this load is different. But this is a syntax. Spark.read format. Load means if load from there. So I'm reading from here. Then I get the data frame, which is the people data people underscore df. I can display that. See here, when I read, it already read the data, metadata. It knows those delta formats, Parquet formats. The schema is built into it, like JSON. It will be built into it. ID, integer, first name, this one, all this information, it knows. You can display that. You can display that. That is what you have seen. That is what you've done this. I just want to quickly revise 5-10 minutes. So it displays. It's just displaying from the memory. It displays the data. Excellent. This is the data. What you have done is you want to write it to. That's what you've done. Who is the Shanmuga? You've done writing also, right? To write, when you write to a catalog. A catalog will have schema and tables. Right now, it doesn't show any schema, any table. So that's where you will be creating a database. See here, one time. I'm just creating a database, name Explorer. I'm creating it. Look here. Okay, it said. If I go here again, catalog, Sairam, you see here, Explorer is the database here. I don't have any tables here. Now I'm going to write whatever this people data frame. I'm going to persist into a table. Look here, people data frame, I'm writing it, save as a table. What is the table? Schema.people data. That's all. I just did two things. Just quick revision. This is saving. When it is saving, what happened? Maybe that already exists. What is that? It says you cannot create table as it is associated with the location. See here, in this location already is not empty. Also not a delta table. So what I'm going to do is look here, right? We can use the format, right? Dot. What is that syntax, Harun? Overwrite. What is that?
Start mode.
Mode, not format. Mode, overwrite.
You can give it as a string inside the brackets. Dot.
Yeah. Super. So it means there is already a data in that. I cannot just save as table. Either I can overwrite it or I can append to it. I can append to that table. So I need to be explicit because in the I already written it. So this is a test system in the sense community edition, where you may not see the catalog. The table is not there, but still the location data is already there. Somehow every time when your cluster is down, they're removing these tables just to save some storage or something like this. No problem. So Harun will show you how to do even transformations. But these 2 points I want everyone to understand. What is that? Let it run. Extract. Your job is most of the time writing ETL jobs, guys. ETL jobs. You'll be extracting mostly from either Microsoft or Amazon, either S3 files or ADLS files. Either they will be JSON files or Parquet files. So you'll be extracting it. You'll be writing mostly to, again, ADLS or S3 files or database tables. That is the main thing you'll be doing. Then in between, the real meat is this. Okay. So read, write. Before writing, I need to do some transformations. So that's where Harun will guide us how to change the column formats, how to change the certain data, how to write it, how to aggregate it. All those things we'll be doing. Then one more point I want to say is the way you store the data. The way you store the data in Databricks is people use the concept. It's not just related to Databricks. They use the concept of bronze, silver, gold. It means as you bring the data, as you extract, there are different layers. This is bronze layer, which is a raw layer. Silver means you change a little bit, you refine it, store in this layer. Then the gold means you do aggregations. Aggregations means how many sales in this quarter, how much revenue in this year. That is the aggregated data. Bronze means raw data. Hey, whatever that is, I'm reading, I'm writing here. Reading, writing here. Reading, writing here. I'm not doing any changes here. Right. Then this layer, Yeah, if you want to do any transformations, do the transformations and load here. So that way you have original data. Even if someone removes this data in the disk, you have in the data lake the raw data, then the refined data, and the gold data. That's it, guys. Most of the time you will be doing this. You'll be doing this. Do the ETL and understand how you store as a delta lake, how you append the data, how you override the data, how you merge the data. All those things are important. Then once you become good in these two, and we go to the real time, which is the streaming. This is also in ETL. But instead of reading from the cloud storage, you'll be reading from the streaming systems. There also, you will do extraction. There also, you do transformations. You load into, again, delta storage. So your job is, when you go to work, you'll be either writing a batch ETL jobs or a streaming ETL jobs. Okay, let's quickly see this. Here, we have written this. If I go quickly, Sairam, explore, I have a people data. I persisted. Sairam, is that correct? Ravi, Portalpalli, I persisted the data. When I persisted, I can see the data here. I can click it and see the data here. See the data here. You know, this is the schema of the table. This is the schema of the table. This is the data. And even you can write, we have persisted this one with, where is this? This is second. All right. I can even see, this is the table. I can describe it. Percentage SQL. Percentage SQL means you're writing a SQL. Describe, just like a Oracle command. Describe. Yeah. Who is that? Ravi? Yeah. See, it gives you what columns, what is the data type, etc. You can describe extended. It means it will tell you where it is storing even. See, this is general describe, right, Sairam? You use it in the general Oracle, correct?
Yeah. Yeah.
Describe extended. Okay. You'll get to know the syntax and all slowly. See here, extended means it not only gives you what column, what data types, it also gives you more information. Like what is the catalog, what is the database, what is the table name, when it is created, what is the last access, location. Please note this, location. Where is the data exist? That location in this Databricks file system, user, hive, warehouse, that is where stored. And what is it a delta? And what is this? This is also type of the table. Is it managed table or external table? There is one more concept you'll be learning in our class. These tables are delta tables. We call them as delta tables in Databricks. Delta tables. Managed versus external. You'll be learning these 2 days. Awesome. Any question, guys, before we hand over to Harun, who will be guiding us a lot of code on transformation related, where the real meat is. You'll be learning and we'll be practicing. Any questions? Does
Yeah,
it make
Quick
Yeah,
question on
Tatamuri? Yeah.
yeah, I have a question. Like, when I ask in our organization, they say like there is no bronze, silver, and gold.
Mhm.
So what that mean? Like, since I know like this is gold is production data, right? So what?
No. It's not. It's a layers. See, again, as I told you, it's how you organize. So if you remember, if you go to grandparents' home, to village, you may not have a what is that? Multiple bedrooms. Oh, this is a kid's bedroom. This is a girl bedroom. This is a master bedroom. That, I don't know. My grandparents, we go, enter, enter, enter. Just it's a long house in the village. So how you organize? Then you went to Bangalore, Hyderabad, you have 2 bedroom. Okay, this is left side, this is right side. So it's how you design. So in general, in organization, there will be raw layer. Venkat?
Okay,
You
yeah.
cannot
Okay.
call it as a branch. A raw layer means bring the data as is. It
Okay.
means immutable.
Mhm.
Then we'll be doing certain changes, change the data. That is called refined layer. Refined layer. Then
Okay.
aggregations you will be doing. Your company needs report. If your company doesn't need reports, they may not have aggregated layer.
Mhm.
Most of the companies need report. Then this aggregation layer, that we call as a gold layer.
Oh, okay.
All of them are in production. In production, that will be there. In dev, it will be there. It's a how you store it is something like this. Venkat,
Okay.
that
Yeah,
makes
got
sense.
it. Yeah, makes sense. Yeah.
Sairam,
Quick question.
Yeah.
This may be too early, but is there any limitation on the volume of data we extract or load or transform?
that is the beauty. Absolutely no limitation. Sai. You can read terabytes of data
Mhm.
because it does in a distributedly, parallelly. If there are more data, you'll be using a number of computers like
It's like horizontal scaling.
horizontal scaling. Good word, Ravi. So you'll have 100 machines, right? This will be getting some data. This will be getting, finally, it will consolidate. That is good. That is good. Good question. Good point.
And
Look,
Srini, I have one question.
Murali.
So I'm seeing that one in the catalog create table as well, right? So we can create the table and load the data into the table. So I don't know, maybe we'll cover later that part.
No, that's a good question. Yes. You can separate. You don't have to, the table can be created in advance. Murali.
Okay.
So if you have, just like in Oracle also, in any systems, you create tables, right, Murali?
Yes,
Just
yeah.
like, you take your SQL, your company in your project is decided we are using 20 tables, just in one SQL script, run it, one time this table is created.
Yeah, but I'm seeing different options there. That's what I'm asking.
There will be different options, right? What do you mean by different options?
Because they're saying one is the upload and the other tab it is saying other data sources. So
No, let's not get confused. So you create a table. This table is a managed table or actional table. Where is it?
okay.
That's it. So it means actional table means you can specify where is the location. Managed table also have a location, but you don't choose the location. Databricks will choose for you. Then rest all only, just like any Oracle table. You will have columns, you will have a description. Murali? Yeah, you'll get to know more.
Yes, yeah.
Shanmukha, Ranjit, Subbu is already here. Sai Charan, Lokesh, Vikas, any question? Super. Yeah, okay. You might have few questions, but they will be clarified as the things go. But I want to have this simple understanding. I'm not oversimplifying it. First, to start with simple understanding, then let's build the complexity. Saira, is that fair? Right? First is, okay, now I understand. I'm going to read and write. In between, I'll be doing transformations. Then complexity, we can start increasing it. But first, you need to have simple understanding. Sairam, is that fair?
Yes.
Super awesome. Harun, Harun has trained so many people. He's a great associate for me. he knows a lot of syntax better than me because I do a lot of architectures and we work very complementary, super. But nothing secret. He says, just practice, just practice. So if you don't know syntax, documents are there. You can Google it. You can, what do you call it? Chat GPT, all those things is helpful. It's not a problem. But if you want to be successful, for that matter, in any career nowadays, you need to have clarity on basics, clarity on the design, clarity on how things all works. Then with some practice, you'll be more comfortable on the syntax. It's not an issue. So don't be worried too much about, I don't know the syntax. Don't worry about it. Syntax, you can learn it as the days pass by. Super awesome. Kiran, does it sound good?
Yeah, Srini.
Okay, super. Harun?
Yep. Okay. Thank you, Srini. Yeah.
Super. I'll be disconnecting after some time. Please
Sure.
carry.
Sure. Yeah. All right.
Okay, bye.
All right. Yeah. Welcome, team. So today we'll be walking through the module 2, basically the ETL, PySpark batch processing. So today and tomorrow, so we'll connect. We'll be doing multiple iterations of the same concepts today and tomorrow. So we'll start with simple things today, and as we go on, we add more concepts to it, like more transformations that what we do. So extract, transform, load, right? So we'll talk about when we extract, how we display, how we make sure what we are reading is as per the format, what we need to do to transform, how we write to a table, what are the various options available, right? So all that we will explore. And then I'll show you some of the hacks, where to go, what to read, kind of files, what are different types of files. So moving on, we will try to read all of those and parse and process those files data, right? Let me share my screen, and then we'll talk about what we are discussing today. So everybody's practiced already creating the Databricks notebooks or the compute from our last sessions, I believe. So if not, please review that and go back and do the stuff, creating the new notebook or adding, creating new compute, adding it and executing. Okay. So in the ETL module, that what we are talking about, PySpark, I think Srini has already touched upon a few things here. So what we are going to talk about, some of them will just do the concepts, because we want to revisit it later when we are comfortable with all the basics and concepts. Some of them will go into detail right now. So extract, transform, and load, right? So in each of these layers, what we have. So extract is, what do we extract? So there are different sources, like, if you take a file, can be a database or it can be streaming. So if you take files, the most common files that we do in industry is CSV and JSON stuff it, and sometimes Parquet. So Parquet is the default, not default, so mostly used format to store the data. Even Spark Databricks, the underlying data storage is all done in the Parquet file format. On that, we have the Delta format that we will discuss. But the lowest level of granularity, how we store the files, is the Parquet file format. So we do read file, parse the columns, parse the data. I will show you that. Schema, what is the schema in the file that is coming in? What are the columns? What is the schema of the table that we are going to write? So how do we parse this? Versus enforce, what schema we want. Read options, what are the options we have available when we are reading. Data frame, so Srini also touched upon a little bit on what data frame is or it is. how we display schema, how we display data. Any questions? Okay. So once you extract this data, the second one is transform. So again, we look at what is a data frame, how we transform it, when we transform it, how does the data frame change? Is it in memory, or it just give you create new object and all of that. Transformations and actions. When we say transform, we write a lot of transformations. So we will understand what is a transformation versus what is an action. And when we are touching that, it also connects to lazy evaluation concept. So this also we will talk about what is a lazy evaluation. Narrow and wide transformations we'll talk about later, not today. Shuffle also. Basic transformations like with column. How do you add a column to the data frame? And basic transformations like filtering the data, group by, aggregations, and joins. And finally, when you load the data to the database or to Databricks to store, how do you write to table? What are the temporary global views? What is the table? What are the write modes available? As we are just seeing, the append versus the overwrite and all that. File location, where the files are stored when you write, read from the table, and display back. Okay. So these are the few topics that we'll touch upon. So I don't want to do more of this. Let's do hands-on here. So I have created a new compute. So I go here. First, I will go and create a new notebook. Create new notebook. Okay. And we'll just name it PySpark batch processing. Okay. So you all know about this notebook, right? So what are the options we have here? So we can write the code. This is called a cell, and in the cell we do a markdown to put comments, images. Python is the default language here. You can do SQL. You can also write Scala and R, as we discussed earlier. Okay. So you want to do markdown. There are some like magic commands you do. If you write %md, it will automatically become markdown to write the comments. Okay. So I go here and say read CSV files and transform and load data in batch. Okay, so that's a comment. I want to add a new code, new cell basically. So I come here, again default is Python, right? So that's that part. Now you see here, I have compute. Let me take this first. Okay, so I created a new compute here, right? And then I have attached it to this notebook. So are you guys are clear creating a compute?
Yes, sir.
Ravi, good. Okay. So
I think there is some question in the chat. Sorry.
Yeah.
From
Yes.
Murdira.
Yeah, I had a question. Actually, I have posted in the chat.
Oh, okay. Sorry.
So earlierly, Srini has said that we will read the data frames, right? So can it be from the local storage or like any other cloud location also? I mean, we can point it to our local storage also, right?
Okay. Local storage is not recommendable. You not connect to your local system and read.
Okay.
So basically, you upload your files to a cloud location and you read from there. Okay.
Yeah,
So normally
yeah.
in the industry also, either you have on ADLS on some servers within the network that you read from. Okay, and then you have a you need to configure, if it is an external system, you need to configure the connections, right? So the system has to be network and ports and security, all of that has to be handled. So normally you don't connect to your local system to read the files. If you have any of your data that you want, it's on your system. Very rarely you do it again. But if you have it, you upload it to the cloud location and you read it from there. That's the standard practice. Okay.
Yeah.
So I will show you, because exactly I have some files on my local. And if I want to read it from here, how do I do it? Okay. So that's where what we are doing next step.
Yeah.
So I have a compute, created the compute to run this and then attached to this notebook. Okay. So as you said, like this compute is temporary. After an hour or two, if you're not using, the compute is closed. Okay. It's dismantled. So again, you create a new compute, new cluster, and then attach to notebook, it'll run. So compute is temporary, but your notebooks is saved, persisted. So you can open the notebook anytime, you log in, create a new compute, and then attach it to this. In the industry, there are always some clusters that are created, right? Some of them are continuously running some clusters. You can automatically use that, or based on what they are configured to use some of the clusters when you run the jobs. And some jobs are like interactive. They are available. You can go and connect it. It will start and then use it, or you can go serverless. Okay. But for this community edition, if you don't use it for an hour or so, it gets dismantled, shut down. So you have to create a new compute again. Okay. So I have a compute here, cluster, temporary, and attached to this notebook. Right. The next part is I want to read data. So as I said here, reading you can do from multiple source files. Where is this? Yeah. So it can be CSV, JSON, or Parquet. Yeah, sorry, somebody has a question? Okay. Now, let's hear, most of you are aware of what a CSV and JSON file, I believe, but let's go back and see what a CSV file and JSON file looks like, just to have something. So CSV file is just a comma separated data. So here movie ID, title, and genres. These are the three columns, you can say, attributes that we have in this file, and the data 1, 2, 3, 4 ID, and the name of the title, and then genres. So please observe here, it is separated by a comma. Okay. So till the point where the comma is the first column, then here this up to here is the second column. And after this is the third column. This is how you have to parse when you read the data. So our end goal is to get all this data, read it, and put it in columns in database table with 3 columns. That is our goal. Now, as you can see in the data, there is this number, year. So this is the year of release when that movie has released. And if you see genres, there are multiple genres, again, which is separated by pipe symbol. Okay. But this is all one string because this is a comma separated file. Only if there is from this comma to this comma, this entire one string. So these are the things. Now, if I want to have year in a separate column, right? So those are the things you do when you cleanse the data or parse the data, then transform. When you're transforming, then you split, saying that, okay, this is the title, this is the year, right? So you have to split that. That is one transformation. You're transforming the data. I have multiple genres. I want to split each genre into a different line, just like explode. In Excel, you do pivoting transformation. That is another transformation you can do. How many genres does this movie fall into? Okay. So this is the data. Any questions on the file formats? So then I have a file format JSON. Okay. This is JavaScript object notation. They call it JSON thing. So here, everything is a key value pair, just like a dictionary, Python dictionary that we were talking about earlier. So this is like a dictionary, key value pair. So what is the key? Key is your column name, you can say, and value here. So they are all in the codes: name, age, city. So with every row, you have the same column. So some rows can have some columns, some rows may not have, they can be skipped. So this is how it is, a simple JSON representation of the data, and it does not have headers and comma separation and all of that. So if you look at more complex JSON, nested JSON, how the data is how the data is formatted. So this is a little more complex JSON nested structure it has. So this from here, if you see from here, these brackets, flower braces. So these braces represent one record. So this is one record, this is one record. So there are two records here. Now, if you take the first record, what I have here is ID, and then name, age. So these are three simple attributes that we have: ID, name, and age. And then I have something called address. Address is not a simple data type. Again, address is a complex data, which is itself a dictionary. Within address, you have, say, state, city, zip, or address line 1, line 2, whatever you want to have. It is all part of this address field. Then I have orders. So orders is, see here, this is again in orders, you have 1, 2. There are 2 orders within this field. So when you have more than 1, it is put in the list, right? We have studied lists and dictionaries in our last session, Python. So this is list. You have more than 1. So this is order 1, order ID, product quantity. This is order 2, order ID, product quantity. I just wanted to give you how different file formats would come in when you want to read. Going forward in one of the sessions, we will parse all of this JSON, and I will show you how to read this JSON, how to parse it, how to explode and bring structure to this in our sessions, parsing JSON files. I just want to show you this. So for now, we will just use the CSV file. Got it? Any questions till here? Okay, that's good. No questions. Now, so I have a file here. Let's go back here, say movies.csv, and this is what I want to read. So as I said, we cannot directly read from local machine. So we have to export it or upload it onto our Databricks environment. So as we know here, the storage, Databricks file system, DBFS. So we can say it's more like Unix kind of a thing. DBFS dot, oh no, not DBFS, one second.
dbutils fs.ls.
Yeah, dbutils dot fs.
.ls.
So you have to give the path here, right? So I just give the root folder. So this is all my folders and files here. So what are the folders I have? File store, Databricks database, Databricks results, and all of this. I can use a display command here to just have better display on this file stuff. Okay, you get a better representation of the data. So this is the path and the name of the files, right? So if I want to go one level deeper to see what are the files in, say, Databricks data sets, so I can do this. So within this data sets, I have all of this. COVID or data set, adult airlines, Amazon, ASA, Atlas Hicks, bike sharing. So all of these files are available within this folder. So you can do recursively and see within each folder what are the files that are available. Okay. So I want to go and add, let's say I want to add within this file store. It's called tables, right? So there is a folder called tables. I'll go and check here. What is the path? Okay, so these are all the existing files that are already there. Now let's say we want to create another folder. You can also do with commands here, or there is a hack. You go here, you just do new table. So you get to this place where you can upload a file. So the default, it goes to file store tables. And here I can give my own new directory. Okay. So let's say I want to say star bricks 2. Okay. This folder will be created under this. Now I click here and then select my file, whatever file I want to add. So say I want to add movies.csv. I just do upload. Okay. This is done. You can click on create table in notebook. You can click on create table with UI. So when you do this, create table in notebook, it will create a new notebook with the, it will generate the code, basically how you want to do all of the creation of the notebook and all of that. But that's fine. So let's not go here. We will do our own. Batch processing here. Now I go and click on tables. So here I know I need to see my own folder that is created here, right? Where is that folder? Okay, let's just check for this. If this folder is there or not. Starbricks 2, see here, we have movies.csv that is uploaded to this location, right? So this is our path where we have our file, right? Okay. Now, what are the other commands if I want to see what this file looks like? dbutils.fs.head, right? And then let's say I give the same path here. So you can see the data. It's not in a right format, but you can at least see what data it has in the file. So this is the data that is there in the file, movies CSV. Okay, got it. So what we have done, we have taken the CSV file and uploaded onto our Databricks file system, right? And then we are able to see the path, and then we are able to display and see the data, some of the data from the file. Now the next part is to actually start reading this file, right? Are you guys all with me? Any questions?
No.
All good?
Yeah,
Okay.
same thing like we can get it from ADLS or S3 bucket, same thing like CSV file, and then we can do, right?
Yes, yes, yeah. So
Okay.
if you are able to access that ADLS or S3 location, I mean, you will be. So when you actually in a industry practice, that's what I said.
Mhm.
All your source location will be given. So you continuously start reading from that location, whatever. So basically you schedule every day, whatever new files have come into that location, you read those files and then process it, and then you move those files to another location. That's how you normally do it in the ETL, right? So you read the new files, process, put the data, transform and load the data and move the files.
So,
Yeah.
Harun, I think I missed one point here.
Yep. Sai.
So even if you have data in the either AWS or Azure, do you still have to upload the data into Databricks storage before
No, no,
you
no,
read? No, right?
no, you don't have to. No.
There is a
We are
concept
we are
called
doing this.
mount.
We are doing this only because it's the local drive.
Yes, because it is a community edition.
Okay.
You have to read from some cloud location, whether it is AWS or S3. From here, we cannot connect. We don't have we have S3 file. I mean, we can create one S3 and give a file and then give open access to everybody, and we can access that from here.
So in real world, we directly read from the cloud storage.
Yes, absolutely. So you can read from either ADLS path, if it is Azure. You can read from S3, Amazon S3 files, or you can read from external databases where you have to configure, right? SQL, when you connect, you give the TNS names configuration, basically your host port, SID, and username, password, whatever SSL, and then you connect to the database, just like
It's called mount point.
yeah. So you can use a mount point, or you can connect to using a connector. You connect to the external JDBC connector. You can also use to connect to the external databases,
Okay. Good.
and then read from there the tables.
Thank you.
Okay.
So basically, like anything, as a data engineer, if you start the job, like so, they will give access to us like ADLS or Azure or S3 bucket, then we can get the access from them. But multiple like databases, like already it is there in the cloud itself, right? So basically, those are we are using in our environments.
Yeah. See, any location you are able to access, you can access from Databricks.
Oh,
Okay. All you have to give is credentials to connect to that location. If
okay,
you have
got it.
access to connect to that location, you can use. So Databricks, within this Databricks also, you have secure credentials that you configure for each, wherever you want to, secrets basically. So use that secrets to store the credentials. Use those credentials to connect to whatever external source, whether it is a database or whether it is a S3 or whether it is a ADLS or whether it is a Kafka topic that you want to read from some Kafka cluster. So whatever it is, all you need is permissions, credentials to connect to that.
Okay.
Then
Yeah.
you can just read from there and everything is same. The
Okay.
source might change.
Yeah.
You have
Different
the
source.
data, everything is a data frame. Whether it is coming from, there's one more thing, whether it is coming from a CSV file, whether it is coming from JSON file, S3, ADLS, text file, Kafka, or streaming, or whatever it is, database tables, SQL Server, MySQL, Postgres, any database, whatever is the source, once you connect and read it, everything is a data frame.
Okay.
That's the
Already.
common ground you come to. And from there, everything is same.
Okay. Got it. Yeah. Got it.
Right. So only the connections you connect to environment, the credentials will change based on what environment you are connecting to and what you are reading from. Okay. All right.
Got it. Thank you.
Yeah, great. Okay. So now I have the CSV file. So let's say I want to read this CSV file. Okay. So I have this. Let's take this code thing from here. So I'm putting this code. So file location, what is my file location? This is not the file location. So this is my file location. So I want to first, give, we can give DBFS or we don't give DBFS, that's fine. It will take automatically default. So we'll just take, this is my file location. What is the file type? CSV. Infer schema, I will talk about it. First row is header. Yes, we know because we have seen the file on the first row of the file, we have column names. So that is my schema. First row is header. Delimiter, I know again is comma. So some files, even if it is a comma separated, they always use a different separator like pipe or colon or whatever, some other character just to differentiate, because sometimes within the text also there are some commas. So to avoid the data being distorted, sometimes they use a different separator. So that's why mostly again JSON is preferred over CSV. But yeah, we in industry we see a lot of use cases with CSV as well. So delimiter again we say is comma. Okay. Now I am declaring something called movies.df. So this is my data frame. So I'll come here. Now I'm reading the file spark.read.format. So these are the options. So, okay, first we give the format of the file when we are reading. Format, what is the format? CSV. Okay. So I am reading a CSV file. Option, infer schema, true. So we are asking the Spark when it is reading to infer the schema by itself. What it means is we are asking the Spark to go through the data of the file in each column and see what kind of data it has. And based on that, you decide what is the data type. So if it is a string, if it has any characters, it will scan the file, right? And then it will decide, okay, this column has all characters, so it is a string. Now, if you see ID, movie ID, it has all numbers, so it will decide as an integer. Now, if there is decimals, it will do as a float or decimal or whatever. So something like that, it will automatically infer the schema. Now we said first row is header. So that's where it will take the column names for that. Separator is again our delimiter. Option separator is what we are giving. It's a comma delimiter. So use the separation. Dot load. We are loading. So we have to give the location where the file exists in our path in the DBFS here. Okay. So if it is S3 or if it is ADLS, you give that location. Plus, you have to also give the credentials object to connect to it. Your username, password, host, and ACL, whatever URL that to connect, of that file and all of that you have to give here. And then I'm using the display. Okay. So just this is all you do to read the file. So once you read this, this will return something called an object called data frame. So here, see, it's running the Spark jobs. Okay. And then it will return an object called movies_df, which is a data frame. So here, if you see, movies_df is a type PySpark SQL data frame object. Okay. So this is the object. And you can also see the schema of that data frame. So data frame is just simple data with structure. Structure in the sense it has data and it has schema, which is your column names and data types. So data, column names, and data types. All three, these three together is a data frame. If you see here, movie ID is integer. See, we have not asked or we have not provided anywhere that my take movie ID is integer, title is string, genre is string. It has automatically inferred that schema by looking at the data. It scanned the data and then it kind of decided, okay, this column is integer, this column is string, this column is string. So now I have a schema here, movie ID, title, and genres, just like we have seen in the in our file, right? Where is that? Movies.csv. Yeah. So movie ID, title, genres, and this is the data. We have numbers, so that is a integer. So if you see here at the top, you can also say it says integer, ABC string, and this is a string. And you can also see when I use display, it will show you the data here. You can download the data, okay? And you can add to the notebook dashboard, whatever in the next level. But this is the,
Arun, I have one question.
yeah.
If you could please scroll it up a little here.
Mhm.
Every time we used to give infer schema true, right?
Yeah.
Here we have given infer underscore schema and header. We usually give true, right? I mean, could you please help me understand this? I mean, hope you got my question.
No, I'm not clear. Yes, we give infer schema true and header
No,
true.
no. So here, when we look at this data frame, movie underscore data frame, in the
Mhm.
options we have given infer schema.
Mhm.
Usually we give it as true, right? I mean,
No. Yeah,
in,
so that is what we are doing. See here, what is this
oh, I'm sorry.
variable?
Didn't see that.
Yeah,
Sorry.
we're just declaring. I know you can just
Okay.
write here true. That will also work.
Yeah. Got
What
it.
you
Sorry, I
want.
didn't see that. Notice.
No,
Thanks.
that's fine. So you can do this. That's it.
So is that how we do it on production? I mean, taking a variable and doing it?
It's up to us almost. I mean, whatever you want to do. Yes, this is a good way.
Mhm.
Normally, so what you do is you declare all your constants at the top in one cell,
Mhm.
variable names,
Mhm.
because it helps the readability and debugging. Okay.
Mhm.
Let's say some variable you are using at 10, 15 places. Now, if I want to
Mhm.
change, I can just go at the top and then do it all at once. So normally how they declare is use something like this. Okay. And then they put, so now you don't hard code in production anyways. All of these come from a configuration file. So you just like a JSON file or something, you store that configuration file somewhere. First, you read the configuration file and get the variables from there. Where is my location? What is my file name? And all of that. Because if you hard code here, tomorrow if that file might change. So you don't know how many places, how many notebooks you are reading that file, how many places you have to change. Instead, normally in any production environment, you always have a configuration file in our environment file where all your locations, options, everything is defined. In any notebook, you first read that configuration file, get the information, and use that information in your notebook. Okay, so today, this is my location. Tomorrow, I might change it to Starbucks 3. Okay, or sometimes the file locations is based on the date stamp. There is a new folder created every day based on the date stamp, right? So every day there is a new folder and the folder name will have that date stamp. So how will you hard code that? You cannot, right? So you have to generate that. So basically all that is written in the configuration file. Then you say this is the prefix and then you do a percent current date and concatenate it, generate the location and then read the files from that location. So all of that you put it there. Normally when you say, yes, all my variables, all my options are read from configuration file. Even whenever they ask in any interviews, you say, yes, we have an environment file. You can say environment file or a configuration file at a fixed location. We first read that configuration file. It mostly it will be a key value pair, just like JSON. So same thing, it will be written in the JSON file, like file location value, file type value, infer schema value, first header available, yes or no, true, false value. So you read all of that into a dictionary, Python dictionary variables, and then use those here. So that when you go and change anything in the configuration file, everything will automatically change here. You don't have to go and change the notebook all the time. Got it?
Thanks, Arun. Awesome. Yeah. Thank you.
So, yeah, that's how the industry standard, that's how it works in production. And it's
So,
also
there is a question from Anshu. She is asking how we can decide that optional. So do we have any values? Depends on the file or depends on the cloud? That is a question from Anshu.
okay. Yeah, so options are all based on the source. So based on the source, you can give as many options you want. So documentation will already be there. Okay. And one thing you can do is basically you can use your AI, or you can just check your AWS. So if you're using AWS or you're using Azure, in the AWS, there will always be options how to write. AWS documentation will give you what options you need to write the file, read the file from the AWS, right? So let's see. If I go here, I don't know whether this is logged in working or not. Okay. If I just say PySpark code to read PySpark code to read file from S3. So the Spark session builder, you can, all of these you can ignore. But see here in the config for AWS, you need your access key and secret key, and then endpoint. So every AWS S3 bucket normally will have just your AWS credentials. You have your access key, you have your secret key. So you need these two to connect to your S3. And then you have your file path, S3A / your bucket. S3 will have a bucket. Bucket is just like a folder. And then your path. So if your movies.csv is on AWS cloud in a S3 bucket called movies, or say historical movies / that folder name / you say movies.csv. See here again, there is another way of reading. You can say dot put all of those options, or you can also use .csv directly to say .read.csv. Then see, you give the file path, you give the schema, but this is already in the Spark what you are reading. You are already setting the configuration for your access secret. So it already has access. It will use to connect to S3 and then go to this path. So similarly, if it is Azure, you will also have credentials to connect to your Azure ADLS, and then you give the path to read. Got it? Did I answer your question?
Yes, sir. Yeah.
Sai Sricharan, how do we connect the current file and the configuration file? Yeah, so I think we discussed this, right? So when you read the file, so I'll show you when you go and read the JSON file. First, you go and read the configuration file just like a same location. So first you know a fixed location where your environment file is. That at least is hard coded. You cannot change somewhere it should start, right? You cannot make everything dynamic. So your environment file location you know already. And then from there you read all those variables from that file. So it will be like a JSON file, key values. So you will have each attribute and its value. But let's not get too deep into it right now. So we are just starting. As and when you progress, you will know all of this. Okay. So let's get back here to our CSV file. And so this is how we have read the data. So let's say dot format CSV. You know what? Let me do.
And also, Arun, if it is a JSON file, this format will change, right? I mean, the infra schema and
Yeah, there is
delimiter
no
will not
infer
be there.
schema for JSON. Right? So you will have the format here as read.json instead of CSV, or you can also give option format. Format you can give JSON here. So there is no first row header and for schema, but you can still create a schema and enforce the schema for JSON. So we will come to JSON, we'll walk through that. We'll work on that. So CSV, read.csv, and then we can give the path here. So let's see. So there are different ways of reading the same file. See, even if you do this, bare minimum, it will still do it. Okay. See, now we have not said given first row is header. So it does not know whether it is a data or it is header. Second, it does not know the column names. Okay. But because it is CSV, the minimum thing it can do is split by comma and put in different columns and then read the file from this path and create a data frame. So if you see the schema here, it just gave some random column names underscore C0, C0, C1, C2 column name, because it does not know we didn't inform it specifically that you have the column names in the first row. So what happened here when it is parsing, it took the first row also as data. So here movie ID also became data. It's not the column name now. So now you see the data is all distorted. This is not a correct data. Now this will fail because my movie ID, I'm expecting numbers. Now the name movie ID has come in that column as ID. So it will get confused. So data is all distorted. This is not the correct data. So this job will fail, right? So that's why what we have asked it to do is we have provided the information that it needs to parse the data correctly. So I have informed it there is a header, which is a column name. So first row is not data. So don't put it into the data. Take it as a header. And from the header, you take the column names, use the separator, data type, you automatically infer based on what data is in the file, and then read the CSV file from this location and display it. So everything in one line, you beautifully get all the data parsed, schema generated with the column names and data and column and data types. Clear?
Yeah, Arun, I have one question.
Yep.
So basically, we would be writing data frame code like using option, right? But we'll not directly give it as .csv.
Yeah,
Yeah.
CS. Yeah.
Yeah.
See, it doesn't
I think
matter.
I'm just thinking, how do you do it on a production? So I just want
Yeah,
little
no. Yeah,
curious.
I understand. Even in production also, there is no standard. There is no one good way or right way or wrong way. Okay. As long as the code is readable, maintainable, and understood by others and efficient, right? It's okay to write. Everybody has their own style of writing code. Okay. So that is okay. You can write option, you can write .csv, both are fine as long as they do the same thing. It has to work. And then it has to be readable and understandable by others if they want to look at your code. Okay.
Sure,
That's
thanks.
all. See, nobody will say, oh, you are writing .option. This is so you are not very expensive. No, everybody has their own style. I want it to be very clear. I write it like this. Okay. I want to be very concise. I write write it like this. Even in this also, you can still provide options. Even if you read .csv also, you can provide options. Okay. So now schema you can also provide schema. If you don't want it to do infer schema true or false, I can also give it schema myself. So how do I do that? Let's see. So this part you are clear how to read a file and display data? Everybody?
I have a doubt.
Okay, good.
Does the order of the input options change the final frame structure?
No, it doesn't care. You can put it anywhere. It'll still work. But only thing is the load should come at the end. You cannot add option after the load. First, it will start putting in all the options, and then it will go and load the file with these options. So if you do first load, then the options will not be available when you load. So that sequence you have to follow. You do the format, you do the options, then you do the load. Load should be at the end. This is all chaining, right, of the options. Okay, you still get the same output. Within the options, there is nothing, you can change it. So let's say if I want to give my own schema, I don't want Spark to infer the schema based on the data. Sometimes, see, it is advisable in production, in industry standard, you give your own schema enforcement. Why? Because two things. One, the files might be very huge. Sometimes it'll have millions of records. Okay. Scanning the file every time just to try to understand what data it is, whether it is a string, whether it is a number. You can have a number at the top, but after 50,000 or 100,000 rows somewhere below, there might be text. So the field might be actually a alphanumeric rather than numeric or string, right? So there is that overhead, and every day, every time you run the job, it has to scan the file and take the data and then try to decide what data type it is. So it's an overhead, right? So that's one thing. Second, we want to make sure the junk data does not come in, wrong data, right? So let's say, as I said, movie ID is an integer. Suddenly some issue happened at the source, and in that column, there are some characters. Okay. Now what it will do, it will try to infer it as a string and it will try to push through. But we want to do integer. So when we say this column has to be integer, when it is trying to load, it will take it as integer and then it will fail or it will throw error saying that this field is integer. You want it to be integer, but I see some characters here. So that's some kind of error handling that is possible when you enforce the schema on the tables, on the data, right? So you're ensuring the data quality here. So it is advisable to give your own schema when you're reading any data. Okay. So how do you give your schema? Right. So let me get that. Go here. Okay. See here how you define the schema. So let's go through this and understand. So Spark has this structure fields in the PySpark Python where you can define each field as a struct field. name of the column, and what is the type, whether it is nullable or not. So this normally you keep true for now. You can explore what are the options within this struct type and struct field. So this is a list. You see here a list of struct fields which are put in a struct type. So this is what you can use as a schema with the Spark. So the same thing we can do spark.read.csv. Header is true because we don't want to get it into the data. And the schema is this. So let's say, not to confuse, I will just use my schema. This is the keyword and this is what I'm passing for the schema. Okay. So the same file. So where is my path? So I have to give this path again to read. Okay. Spark.read.csv. As we said, this is one way of reading the file. And this is one way of reading the file. You can give format options and all of that. Or you can give .csv and then comma separate inside. You can give the options again. So what are all the options that are available? You can check the documentation. What you can give when you do spark.read. So do this schema and this is my schema. When I run this, first it'll throw error because the struct type is not defined. It does not know what is a struct type and struct field, right? So for that, you have to first import these. You have in the library. So you first import from PySpark.sql.types, you import the struct type, struct field, integer type, string type. So these are different classes, you can say libraries, you can say that are used. So you first import it from this package and then use it to create the schema. Okay. Now I say display data frame, DF.
So every time we need to import Harun, or once we can import everything, it will be there.
What do you mean every time? It's just part of the notebook, right? So every time you execute, it will already be there. It will execute this. If you are using
Okay.
it again next time, then you don't need to import. Within this notebook, if you import once, that is good enough.
Okay. I mean, the next cell, we don't need to import again, right?
No, we don't need to.
Harun, here we will not keep any delimiter, right? In this process here.
Yeah, it's just a comma delimited by default.
Okay.
You can also give, I think, let's, you can try that various things, how we want to do. First. But you have to know what is the keywords that you have to give here. So it says, it always says, perhaps you forgot a comma. Okay. See, so you can just add comma all your options here. This is a separator. This is a header, schema I gave here, path I gave here, .csv. First attribute is the path, and then you can give your options. Good. Now, I want to do some operations on this data frame. So you can do transformations on this, or let's say you want to write it to the bronze table here. As is data, whatever is you're reading, you want to write it to a table. So first, I will create a database. So for that, I just go into a SQL, okay, and then say create database bronze. Okay, so bronze database is created. So I can go here, go to catalog and see here there is bronze. There are no tables here yet. Now I go here, take this data frame and just write it. Go here. I can do any data frame, right? So both are same. So this data frame I have read df. This data frame I have read movies.df. So I can do movies underscore df dot write. Okay. Dot again, see, there are different formats you can write to .jdbc, .csv, .parquet. So you can also write it as a file, or you can write it to a table, delta table. Okay. So we'll just go here, take this, whatever we are, writing. So this we are reading. We can create multiple databases. So let's say I just want to write to a bronze table. So table name, I have wrote bronze dot movies. Bronze is the database. Movies is the table name. Okay. Bronze table name, I have declared a variable. And then I wrote data frame dot write dot format. I am giving delta. So this we will cover later. What is a delta format? What are the various features of the delta? How it is a core engine of the Databricks thing. What are features that it gives us? So all of that we will discuss in a separate, its entire module by itself. Dot mode, we have seen overwrite, and then save as table, this table name. Okay.
Harun,
Yeah.
I have a question. So we are writing dot mode override, right?
Yes.
So if the file already exists, we will use this command, right?
Not file.
Okay.
And the
I knew.
table.
Okay.
Every time we are overwrite, it's like whatever data is there in the table, you delete it or truncate the table, clean it out, then put this data into the table. That's what overwrite means.
Okay.
Okay. It's not the file. So let's go here. I want to write into the table.
Also, we are opening a new code section for everything. Do we do same thing in client place also, or do we do everything in one code section?
It's better, right? So it's modularization of your code. Each cell you want to do some specific activity. So you read everything you want to put in one cell. Your SQL you want to put in one cell. Your next write or transformations you want to put in one cell, so that it becomes easier. It doesn't matter because when you run it, it will run in sequence. When you are writing it, you can interactively run whatever cell you want.
Okay.
But when you run as a notebook, it runs in sequence from top to bottom.
So you click on that run all button.
Yeah.
If you want to run the
You
entire
just
notebook.
run all button, it will run from the top everything.
Entire notebook.
Entire notebook, yes. Okay. So this has run. So we will, all these jobs we will do again in another separate module called Spark internals. We will come there. But for now, this has written the data into this bronze. So we go here, the catalog, bronze. See, now we see the table here, movies. See here, you can do refresh. You can see what is the schema of the table. Same movie ID, title, genres. This is the data type, sample data in the database. Okay. You can also see history. See, again, this is part of Databricks Delta that we will cover later, but at a high level, these are the versions that are created. Create or replace table 0, 1, 2. On July 27, we wrote this table. And again, on August 3rd, we are writing the table. So this is the new version 2. So the table already was there at that location, that file path, that meant metadata basically. Okay. Now, so we go back here, take another cell. You just say, movies equal to spark dot read. See, now I'm reading from my Databricks. So I will just say table, and then I will give the table name here, bronze table name, whatever I have declared. And display movies. What happened? So, cannot be found. Uh-oh. So sorry, I put it in the strings. It is a variable, right? Yeah. So you're just reading bronze.movies table here from the database and displaying it. So you read the file, you wrote it to the Databricks, and then you are reading it back from the Databricks table and displaying it. The same thing. So read, write, and then read it back. So we haven't done the transformation part as of now. Okay. We have only done the read and write to the database. We created the database and we wrote it to the database. Now, so this part you're clear, reading the data frame and then displaying it. Anybody, any questions? Ranjit, Sai, Sricharan, Srikanth,
Clear, Arun. Yeah.
everybody? Murali? Murali, are you following?
Yes, sir. Yeah, I'm good. Yeah.
Okay, nice. Shanmuga,
All good, Arun.
heard your voice today. Shanmuga, Vikas. Good. Okay.
అది నోషిత నేమ్ ఏమని పెట్టను ఫుల్ నేమ్ పెట్టాలా నోషిత ఎంటెడ్ అని
Sorry.
ఒకసారి నేను ఒక ఫోటో
Okay. Yeah. So this is about it. Now, let's say I want to access. We said this is the database, right? Table. So we should be able to get it, write SQLs on this, correct? So let's say select star from. This is my database, bronze dot movies. Can I get this? Absolutely. So you can access the database table using spark.read and get it as a data frame, or you can directly use Spark SQL. Just say SQL, select star from your database dot your table name. So basically here, again, this is the Hive meta store. So I think that's a different concept, but when you use Unity catalog, there will be 3-layered namespace. So like there will be a catalog name, then database name, then table name. There will be one more layer here. Okay. which could be your, say, your catalog, maybe, dev. So dev dot bronze dot movies. So the same table, when you migrate to higher environments, so maybe you can have dev instead of, then you can have PRD as prod as a one catalog, or you can have by domains marketing as one catalog, sales as one catalog, data science as one catalog, something like that. So just another division, you can say. Most of the other databases you might have seen also have, like in Oracle, something like you have a database, then you have a schema, then you have a table, right? Something like that. In the Unity catalog, then we go further into the deep into the sessions, we will talk about that, what Unity catalog is. But there you will have catalog name, schema name, and the table name. So just for your information for now. So here select star from bronze dot movies. You get here. You can write all your SQL here, where movie ID equal to 5. Yes, you get this. Okay. So all SQL you can write on these tables. And you can interactively change this, use this, whatever you are getting this information, data from SQL, you can copy it again into a data frame interchangeably. Okay. So here you can see underscores SQLDF. This is automatically available in this cell as this. So you say my copy df equal to underscore SQLDF. No, not his name. So let's take another cell here, underscores df, and then display copy df. See, I was able to get into a Spark data frame, the same data I got from SQL. You want to write a complex SQL, joins, where class, group by, aggregates, everything, write a SQL, execute it, and then you can take it into a data frame if you want to do any further processing on that. Or if you want to write it into another table or another view or something, you can just interchangeably copy it here. The same thing you can also do from data frame. You can take it to a SQL kind of a thing as a schema thing. So you can say, let's say I have here, let's go back. Okay, so we'll come there, how to register temporary file and all of that. So before doing that, so we have mode dot overwrite, correct? So after this, I want to add a code cell here. SQL count from bronze dot movies. How many rows I have? 9,742, right? Now I will run this again. So I am again writing into the table the same movies data frame data back into the table. Now I run it again twice and I do this. So the count is still 9,742. It has not changed, right? Why it has not changed? We are overwriting the data. So we are deleting the entire data, truncating the entire data, and then writing the new data onto the table. So it will be the same. Now what happens if I change the mode to append and run this? Run this. Now I run this. See? Double. So append is you're just adding the entire data again to the table. So if you put append and leave it, every time you run, the entire data is just appended to the table. So you get duplicates data. So if you run again, you'll get 3 times.
So this gets loaded as a raw data with no indexes or anything on the tables?
Yes. So we don't enforce in the Databricks, mostly in the data engineering Databricks, we don't enforce the primary key, foreign key concepts. Those are all virtual, right? So not at the table level. We don't enforce. How do we enforce that relationship is when you write, you can add constraints. So that constraints are defined when you use DLT pipelines or whatever pipelines. Use the constraints to either fail when the constraint fails. You can put a unique key constraint on the on a particular ID, say movie ID. Now, when you get a duplicate, it might fail. So you can ask to ignore or skip or fail whatever action you want to take that you can configure. That's one way of doing it. Other way is you normally don't do append or override. You normally do merge unless you. So if it is a raw layer, yes, you every day you just get incremental data and then you just append it to the raw layer. From there, you read into the silver when you are doing transformations. You read data only based on the timestamps or from the previous run, whatever job that has run previously. You take incremental data from this and process.
So what is the difference between that append and merge?
Okay. Merge is basically what you do is it's an upsert. Okay. Merge is upsert, meaning you update or insert. So here you give the keys. So movie ID, if I want to give, you say merge, use this table, and on you give the keys, input, incoming data, and the table data. So I define movie ID as key. Then what it does is it first matches that ID with the data in the table. If it finds a match, it will update that record. If it does not find a match, it will insert that record. So we will do this also later when we do the merge statements. So you can write different conditions when matched what you want to do, when not matched what you want to do, all of that you can do. Append, it does
Append,
not
I understand.
check.
I understand.
Append, it does not check. It will just keep adding all the data.
Yeah.
Overwrite is the other way around.
Yeah.
It doesn't
Deletes and
care.
writes.
It will first clean entire table and just write it.
Yeah.
Okay. So merge, you cannot write like this. Just you cannot put merge in the mode. Merge is a different entire statement that you have to write. This it has a different syntax. You have to define what is the source table, what is the target table, what keys are you matching. Then when you match what you want, what action you want to take. When it does not match, what action you want. So all that you have to define in the merge statement. That we will come to it when we get there. But for now, just focus on append and overwrite. So you should also understand when to use append, when to use overwrite. Normally, overwrite is you do when you do aggregations in the gold. So when you're calculating the entire data, aggregating, say group by and aggregate, you will overwrite. I want to just have the fresh aggregations. normally in the raw layer, every day you are getting some incremental data, you just keep appending to it. So now I have here append 3 times 29,000 rows, 3 times I ran, it keeps adding. So I will change it to overwrite and then execute. So it will delete all 29,000 rows and just add the data that we put in, 9,000. Okay. Is that clear? Everybody reading and writing. That's what we did today. Transformations we will do tomorrow. So extract and load we did today. Are you all clear? Any questions?
So one question. So when we
Mhm.
are creating the table, right, we are writing as a save as table.
Mhm.
So that time there we can't define which is the primary key something.
No, it just try to match the data frame columns as a your table schema. If it does not match, it will not write. It will throw error. If you don't want to do that, then you can convert it into a schema, like transform the data, use filters or select some columns, and then you can write it to the table.
Okay, so it is just whatever the structure, it creates the table and loads the data. That's it.
Yes. Yeah. If the structure is already there, it will just load the table as per the schema that it is.
Okay.
Yeah. Partial, like insert only 1 or 2 columns and all, it cannot. It has to
Okay.
match the schema.
So just
Schema.
like SQL loader, what it does.
Yeah.
The same way.
Okay. So it's just the reading part, writing part. There's a lot of power there in the transformations. That's where the whole meat is, all logic transformations, how we write the functions, how we transform the data, how we enforce the data quality and all of that, how we cleanse the data. So all of that is done in the transformations that we will see tomorrow. But for now, I will post this, both the video and the notebook. Please go through it, do your own, create these files, and then do the hands-on. Okay. Now, how do you get this? There is a, that Kaggle, right? This Kaggle data set, the Kaggle site where you have all the data sets. I think in this you will also have movies data set that I'm currently using. That file that I'm using. Okay, I will give you that URL as well to download the data. Not this one, I guess, I believe. Yeah, I will give you that as well. Okay.
So if you want to download that notebook and share it with someone, how do you do that? You can just do the file save as.
No, you go here and do publish. Okay.
Oh, okay.
So when you do publish, it will give you this link. Now you copy this
Oh, it gives you a link. Okay.
Yeah, copy this link and then you send it, you post it. Anybody can open this. This gets exported. So then you can go and import into your own environment. So how you do that? That's a good question. You go here. So when you do new notebook, oh, not here, sorry. So you so file, import, right?
Mm.
You do a notebook, you go file, import, and then you can do URL here and then paste this URL and say import. Okay. So then it'll get imported. The notebook will get imported to your environment. Now check the path. basically, and where you are uploading your CSV file to, and adjust the path, everything should run fine. Okay. All right. I think we are at time, so I will publish all of this update. Let me know if you have any questions. All good, everybody? How does that feel? Anybody feeling difficult or kind of a thing, or you feel it is easy, simple? How do you see the power of Databricks Spark processing? Come on, guys. How do you feel the session? Lokesh?
Yeah, it's very informative, but I think we still need to do a lot of practice.
Okay. Nice. Yeah, you need to do the practice, but at least the concepts, you are good.
Yeah.
Concepts are good, Harun. But
Okay.
main thing is the syntax is somewhat difficult. But if we practice, it will be familiar.
Yeah. See, syntax is the last thing you should worry about. As I said, right? You just go here, ask, it'll give you the syntax.
Okay. Yeah.
Yeah. And don't worry about the syntax. You just have to know what to do. How to do it you can get. It's not
Yeah.
a big syntax. You have Databricks, itself, the documentation from Databricks. So if you go here on data frame, to here, see data frame here. Go to documentation. Whatever you want, you will get here. So what you need to connect, data sources, storage connections. You don't need to go here right now. You'll get confused. So just practice whatever we have right now. That should be good, because you'll get a lot of more concepts here. You will get confused if you straight away go here.
So Harun, maybe it's an advanced question, but the question is, Databricks already there, right? But why we need to use the Azure Databricks?
Well, I didn't get you. Can you come again?
No, why we need to use the Azure Databricks? Because Databricks is separate, right? But why we need to go to the Azure Databricks?
So Databricks is a platform, as analytical platform, processing, right? But the storage is on one of the cloud partners. All the files, the clusters, the machines that they run are provided by the cloud partners. Like if it is Azure or AWS or Google Cloud, Databricks sits on top of that to run. The machines, the underlying machines are provided by when you create a compute, right? So those machines are given by Azure or Amazon clusters. When you store this data, where is those files underlying stored? You're storing in the DBFS, but that is also sitting on top of the Azure storage only, or AWS storage only. So the underlying storage and machines are right now provided by one of these cloud partners. So where Databricks runs. So Databricks you can choose your cloud storage part. So on top of that, your Databricks will run.
Yeah, when I'm logging to the Azure, right? So they're giving the same Databricks. So we can use that one as well, right? I mean, from the Azure account, we can use the same Databricks.
Yes, absolutely. You can use that. But I think that is charged, right? When you use those Azure, whenever you have clusters. And yes, that's what we said. We will also do that after few sessions. We will go and create the Azure, the Databricks namespace service on the Azure and do some streaming and all of that. But for practice, this is free. Your
Community
compute,
edition.
your storage, your cluster, everything is free here, community edition. So you do practice here. Then when you want to do some advanced use cases like streaming and all of that, then we go and use the Azure Databricks account and create there and do, because they will charge for the compute there.
Okay, got it.
Right? Yeah.
I think the cloud are also providing some free services, Arun.
Cool.
Even cloud is providing free services.
Yeah,
We
there
can
are
make
some free services. Some basic
Yeah.
tier will be there, but some use cases where you are using, they are charged because everything is not available. If you in the free tier, if you spin up the Databricks, see you have here catalog, but you don't have the
workflow. We don't have workflow.
workflows and SQL where you can run and
SQL warehouse, yeah.
and all of that, right? So those are all charged. And if you want to have Azure Event Hub for streaming, so for that they charge. Some of the events clusters that you bring up, they are charged. So some are charged, some are free. So we don't want to go there straight. So we first want to do practice here, everything when it's free. Only where required advanced use cases will go there. Okay.
Yeah.
Okay. All right, guys. Take care. Thank you so much. Appreciate it. If you have find any difficulty, please reach out to me offline as well. Ping me. We can talk. Okay. But don't worry. This is all very simple. Everything is available. Syntax, code, everything is available these days. Everything is AI. All you have to do is understand the concepts. That's all. What are my sources? What is my target? What I'm reading, where I'm writing, what transformations do I need to do for data quality, or what aggregations I need to do for reporting or analytics. This is what you need to understand. What are the various available options, components within the platform for me to use, right? What is Databricks Delta? How does the format work? What are the features available? What is time travel? What is delta sharing? All of those things. Concepts are very important to understand and do some hands-on practice. Okay. Absolutely don't worry about the syntax. Nobody's going to ask you syntax. Even in the interviews also, nobody will ask you the syntax. Even in the job also, you have a lot of help in terms of syntax. Okay. So that's what they're saying. In the next 4 to 5 years, absolutely, you don't need to write any code. Everything, 40 to 60% of the code right now is generated, is all AI generated. Okay. So you don't need to worry about syntax, about writing thousands of lines of code to do anything. Very minimal code. You get here, in the production, you also get the co-pilot kind of a thing, AI help. It will automatically do all it will generate the code. You put it, you run it, errors, you ask it to fix, it will fix it, it will give new code, you put it, you run it. So all you are doing is correcting, trying and correcting. That's all you do. Rest all the system will automatically take it. Databricks itself will give you that assistant, AI assistant, to help you with coding things. Okay. Just focus on the concepts. All good, everyone?
All good, Arun.
Yes, sir.
Yes,
Okay.
sir.
Yeah. Any other questions before we close for today? All right.
So far, I'm good, Arun.
Okay. Thank you so much. Let's meet tomorrow. It will take some time for me to post these, maybe a couple of hours. But hopefully, yeah, I will post the video and the notebook link. Okay.
Sure. Yeah.
Thank you, guys.
Thank you.
Have a
Thank
good
you.
rest of the
Thanks,
day.
Have a
Arun.
nice day.
Thank you. Bye.
Thank you.
Bye.